Hello, everyone. Today, we're going to talk about chapter 2, part C. In this part, we're going to talk about how to achieve competitive advantages through outsourcing. So what do we mean by outsourcing? Outsourcing means buying materials or components from suppliers instead of making them in-house. And outsourcing also means transferring activities to external suppliers. For example, Gap outsources the production of clothes to other countries, and Johnson & Johnson outsources manufacturing to contractors. We'll talk about two questions. First of all, what activities or components should we outsource? Next, if you decide to outsource something, how can we select the supplier? So let's start with the first question. What activities or components should we outsource? For example, should Apple outsource their product design or manufacturing? How about their product design? They can't outsource their product design because that's what they do best. Product design is one of their core competencies. So they probably shouldn't outsource their product design. But on the other hand, they can consider outsourcing manufacturing because manufacturing is not one of their core competencies. There may be other companies who are better at manufacturing than Apple does. So here's a theory we can use. It's called the theory of comparative advantage. It says, if an external provider can perform activities more productively than the purchasing firm, then the external provider should do the work. We can translate this as follows. A firm should focus on what it does best, its core competencies. On the other hand, non-core activities are good candidates for outsourcing. So let's think about why a company should consider outsourcing. There may be advantages in cost and quality. A single car has about 30,000 parts, and Honda can specialize in making all of its parts. Sometimes the firm can get cheaper and higher quality parts from suppliers who specialize in particular parts. Another reason is insufficient capacity and lack of expertise. For example, Honda won't have enough space to make all of the 30,000 parts in its factory. It won't have the technologies for all of them. On the other hand, why does a company consider making something in-house? There may be several reasons. First, we want to protect proprietary technology. In other words, we want to protect the patented technologies. So what do you mean by a patent? You get a patent when you have a new idea. When you patent your idea becomes available to the public, but no one else can use this idea without your permission. So let's think about how companies make a profit by getting a patent. Let's say there is a biotech company, and this company develops a new drug that can treat a lung cancer, and this company gets patent on this technology. So when this technology is patented, it's available to the public, but at the same time, no one else can use this idea without the permission. So how can this company make a profit from this patent? If it produces the new drug in-house, there's no one else who can produce the same drug, so there is monopoly. The company can price it as high as possible. So that's one way to make a profit. There's another way to make a profit. If the company doesn't want to produce the drug in-house, it can license the right to produce the drug to another company. When the other company makes a profit by producing the drug and selling the drug, for each dollar it makes, it has to pay a certain proportion of that dollar back to the original company that holds the patent. And this payment is called a royalty payment. So the company with the patent doesn't have to do anything, but it makes a profit by collecting royalty payments. So that's how a company makes a profit, by getting a patent. So why does the company want to produce something in-house when they have a patent? What happens if a company licenses the right to use the technology to another company? The other company uses the technology to produce the products, and they make royalty payments, but there's always a risk. The other company can develop similar technology on their own, and they can be a potential competitor in the future. So that's one of the reasons. So we have a patent, so we want to produce something in-house, or another reason why a company considers making something in-house is there's no competent supplier. In other words, no one can make it better. Now, better quality control. We want to control the quality more directly, and control of lead time. In other words, we want to get it faster. If you make something in-house, you don't have to wait for your supplier to deliver. You can save transportation and housing costs, warehousing costs. If you make something in-house, you don't have to pay your supplier for delivery. You don't have to pay your supplier for warehousing. In other words, you can save money on shipping and storage and use existing idle capacity. And that means we have extra space and extra labor, and we want to use it. So in this table, I summarize the advantages and disadvantages of outsourcing. What are the advantages of outsourcing? Cost savings, gaining outside expertise that comes with specialization, improving operations and service, maintaining a focus on core competencies, and accessing outside technology. What are the disadvantages of outsourcing? Increased logistics and inventory costs, loss of control, potential creation of future competition, and risks may not manifest themselves for years. In other words, there may be hidden risks. For example, let's say you have a supplier and the supplier goes bankrupt all of a sudden, and you didn't see it coming because you don't have any information about their financial status. So you have to find another supplier. So this is a hidden risk. Now let's move on to the next question. Once you decide to outsource some item, how can you choose a supplier for that item? How do we choose a supplier when there are multiple criteria? We'll talk about two methods: the average weighted sum, AWS approach. Sometimes this is called the factor rating method. And the other method is called fix all but one method. Sometimes it's called the service level agreement approach. So let's start with the average weighted sum approach. I want to start with an example. Suppose you are a mechanic trying to find a supplier for your batteries. The following four suppliers have made an offer to you. You have two performance criteria: the cost per unit and the percentage of defectives. Supplier A charges $100 per battery his shipment usually contains 6% defective items. B charges 105, contains 2% of defectives. C charges 93, contains 4% defective. D charges 83, contains 10% of defectives. So which supplier should you select? Now let's plot these options on the XY plane. On the x-axis, you put the price, the cost per battery. On the y-axis, you put the percentage of defectives. So A has 106%. B has 105 and 2, so 105 and 2%, etc. So first of all, let's eliminate dominated solution. What's a dominated solution? A dominated solution is a supplier whose performance is worse than another supplier in every aspect. For example, A is a dominated solution. This is dominated by C. Why? Because C has a lower cost. Let's look at the cost. C has a lower cost than A. So A is dominated by C in terms of the cost. How about the percentage of defectives? C has a lower percentage of defectives than A. So A is dominated by C in terms of the percentage of defectives. So A is dominated by C in every aspect that we consider. So we don't need to consider A any longer. So A is eliminated. Now we can focus on B and C and D only. Now let's think about extreme approaches. Let's say I don't care about the percentage of defectives. All I care about is the cost. In this case, which one should you pick? All I care about is the cost, so you choose the cheapest one, which is D. Let's go to the other extreme. Let's say I don't care about the cost. All I care about is the percentage of defectives. Which one should you pick? The one with the lowest percentage of defectives, which is B. So, but this doesn't happen a lot in practice. These are very extreme cases. So what should you do? How about making a compromise? This is called the average weighted sum approach. So in this approach, we're going to assign a weight to each performance criteria and then compute the weighted average, weighted sum, actually. So let's say I think the cost is 20% important and the percentage of defectives is 80% important. So I want to assign a weight of 20%, 0.2 to the cost, and the weight of 80%, 0.8 to the percentage of defectives. And we can compute the global performance of each supplier as follows. So the cost, you take the cost. What's the global performance of supplier A? You take the cost of A and weight this by the weight, which is 0.2, and take the percentage of defectives multiplied by the weight, and then add them up. Then you get 24.8. That's the global performance of supplier A. And we can repeat this for each of these suppliers. Take the cost of B multiplied by 0.2, take the percentage of defectives and multiply by 0.8, add them up, you get 22.6. And repeat this for C and D, you get 21.8 for C and 24.6 for D. So once you have all the global performance for all the suppliers, which one should you choose as the final choice? The highest number or the lowest number? So to answer this, you need to look at each performance criteria. If you look at the cost, which value indicates better performance? A lower value or a higher value? A lower value means lower cost, so it indicates better performance. The lower the cost is, the better the performance is. How about the percentage of defectives? If you look at the numbers, which value indicates better performance? A lower value or higher value? A lower percentage means a lower percentage of defectives, which is better performance. So again, in this criterion, a lower value indicates better performance. So in both cases, a lower value indicates better performance. So in the global performance, you should pick the lowest value that represents the best performance. So pick the one with the lowest value, which is supplier C. That's going to be your final choice when you use the weighted sum approach. Now, let's think about the weaknesses and strengths of this choice, of this approach. The strength is that it's easy to implement. You can just compute these global performance and pick one of them, the best one. The weaknesses are it's very hard to determine the weights. How do you know? The cost is 20% important and the percentage of defectives is 80% important. And it's not clear how to determine the weights, and there's no clear guidance on how to choose the weights. So in the let's try another example. National Architects, a San Francisco-based designer of high-rise office buildings, has decided to outsource its information technology function. 3 outsourcing providers are being actively considered, one in the United States, one in India, and one in Israel. So in this table, these are the factors that you're considering, and you are given the weights for these factors. And inside the table, you're given the ratings of these 3 suppliers. The higher the rating is, the better the performance is. So the first thing you need to do is compute the total weighted score for each supplier. So how do you compute the total weighted score for the supplier in the United States? So you take each rating, 3, multiplied by the weight, 3 times 0.2 times, and then 4 times 0.2, 5 times 0.2, 4 times 0.1, 5 times 0.1, 4 times 0.1, 2 times 0.1, times, and then add them up. You get 3.9, right? And then you repeat this for the rest of the suppliers. So for the supplier in India, you take 3 and times 2.2, 3 times 0.2, 4 times 0.2, 5 times 0.1, 3 times 0.1, 2 times 0.1, 3 times 0.1, and add them up, you get the global performance. And you repeat this for Israel too. Then you have 3.9 for the United States, 3.3 for India, and 3.8 for Israel. So once you have these, which one should they pick? Should they pick the highest value or the lowest value? To answer this, you need to look at these ratings and see what they represent. Does a higher value indicate better performance? Yes, right? So that means the higher score indicates better performance. So you need to choose the one with the highest score, which is the one in the United States. Now, I mentioned that this approach is highly sensitive to the choice of the weights. So in the next approach, I want to introduce something that doesn't depend on the weights. This is called fix all but one approach. Sometimes it's called service level agreement. In this approach, we're going to select the most important criterion and identify targets for the rest of the performance criteria. And we're going to try to optimize the most important performance criteria selected while meeting the targets in the rest of the criteria. So let's look at the previous example where you want to select the supplier for your batteries. You have 4 suppliers, A, B, C, D, and you are considering 2 factors, the cost and the percentage of defectives. And you have, let's say, you think the cost is the most important factor. And for the percentage of defectives, you have some target range, 8% or less. If a supplier has 8% or less defectives, then you'll be satisfied. So in this case, how can you select your supplier? First of all, you're going to find all the suppliers who satisfy the target range for the percentage of defectives. So does A satisfy the target for the percentage of defectives? A has about 6% defectives, yes. B, yes. C, yes. D, no. D is not qualified. So of these 3, who achieves the minimum cost? C, right? So the answer is C. Now you can see that your answer, your final choice, depends on which criteria is the most important to you and what target range you're going to set up. So for example, let's say that now you think the percentage of defectives is the most important factor. So for the cost, you only have some target range. You will be satisfied as long as the cost per battery is 95 or less. So in this case, how can you make the final choice, right? So you go through the suppliers and see if they satisfy the target range for the cost. So does A satisfy the target cost? No. B, no. C, yes. D, yes. Right? So we have 2 suppliers who are qualified. And between these 2, how do you make the final choice? You choose the one with the minimum percentage of defectives, which is C, right? So in this case, you're going to select C. Okay. Let's try one more exercise problem. Suppose you are managing a production line that produces bottled soda. Plastic bottles are outsourced from a supplier, and here are 5 options given to you. We have 5 suppliers, A, B, C, D, E. There's the cost per bottle, which is 10 cents, 12 cents, etc. The delivery time is 5 days, 6 days, etc. The percentage of defectives, 3, 4, 2, etc. A, find the best solution according to the weighted sum approach. Apply weights of 0.5, 0.2, and 0.3 to the cost, time, and percentage of defectives. Right. So how do you compute the weighted sum of a supplier A? Right. Take the cost 10 times the weight for the cost, which is 0.5. Next, the delivery time, 5 times 0.2. And the percentage of defectives, 3 times 0.2. So that becomes 6.9. So you can repeat this for each of the suppliers and compute the global performance of each supplier, like this. Now, once you have this, how can you make the final choice? Should you pick the highest one or the lowest one? So it depends on what value indicates better performance. If you look at the cost, does a lower value indicate a better performance? Yes, the lower the cost is, the better the performance is. lower value. Now, if you look at the delivery time, does the lower value indicate the better performance? Yes. Lower the delivery time is, the faster we can get the product. What about the percentage of defectives? Does the lower value indicate better performance? Yes, right? So to summarize, a lower value indicates better performance in the global performance. So we should pick the one with the lowest value. Now let's go to part B, identify the best solution when you minimize the cost of a bottle. So the cost per bottle is the most important factor. And for the rest, you have to set the target range. The delivery time should be 6 days or less, and the percentage of defectives should be 3% or less. So first of all, let's see who are qualified. Is A qualified? Delivery time is less than 6, percentage of defectives is less than 6. So yes, A is qualified. Let's go to B. Is B qualified? 6, this should be less than 3. So B is not qualified. C, is it qualified? Less than 6, less than 3, yes. D, less than 3, 6, less than 6, 3, yes. E, less than 6, no, not qualified. So you have 3 suppliers, A and C and D. And between A and C and D, which one should you pick? The one with the minimum cost per bottle. So A, C, D. The one with the minimum cost per bottle is A. Now let's go to part C, identify the best solution when you minimize the percentage of defectives. So the percentage of defectives is the most important factor. So for the rest, you have some target range. The cost per bottle is 15 cents or less. The delivery time is 5 days or less. So first of all, you select the qualified suppliers. Cost per bottle, is it less than 15 cents? Yeah. Delivery time less than 5 or less? Yes. So A is qualified. A is qualified. Let's go to B. 15 or less? Yes. 5 or less? No, not qualified. C, 15 days or less? 5 days or less? Yes, qualified. D, 15 cents or less? No, not qualified. E, 15 days or less, cents or less? Yes. 5 days or less? No, not qualified. So in this case, we only have 2 suppliers who are qualified, A and B, and between these 2, which one should we pick? We should pick the one with the minimum percentage of defectives. So the percentage of defectives for A is 3%, for B it's 4%, so you should choose A. A should be the final choice. So this is everything we have for this part. I'll see you next time.